thank you all for attending. This webinar series we started last year with the Forest Service, and we've had some great presentations, a lot of very good, very useful information about biochar. And we've been at biochar now for about 15 years, and so this is a good time to look at the links between woody biochar, forest industry, agriculture, and benefits for different uses. The point is that biochar is now extended from relatively simple carbon. We were inspired by terra preta in the Amazons, and now it's really extended out into the marketplace and touches a lot of lives, and hopefully it will grow. So for treating the topic, I'd like to talk about what sound like cliches: value chains, carbon connections. You see the structure of cellulose there, the string of carbon that makes up the carbon in cellulose and in woody biomass, and what we're calling the green carbon economy, transition from fossil fuels to green carbon base. And on the right, you can see, for example, biochar. That's a product from a biomass plant, conversion of woody residues, both forest and mill residues. And this is the small residue that you can pull off of combustion. We'll look at that. Below, there are a couple of industrial devices that have evolved over the last 15 years or so. Char Technologies in Canada, and Earth Care in Ohio. So as Carlos described, the USBI is a nonprofit organization. Our tools primarily are networking, education, demonstration. We've enjoyed the support of the Forest Service for the last 2 or 3 years. We've been in existence since 2009. We put on conferences, about 7 or 8 conferences and workshops. In addition to that, we put on workshops and demonstrations. We put out a newsletter. You can go to our website where we have a learning center and directory. We're active in social media, and we have a discussion group called biochargroups.io that has a wide range of people with different experience, a lot of experience with biochar. So our vision at USBI is to leave a legacy of fertile soils and sequestered carbon, to raise the awareness of and increase the utilization of biochar through collaboration with organizations involved in the production, application, and research. Now, the U.S. Department of Energy tells us we have 1 billion tons of biomass, and of that, I think it's about 250 million tons of woody biomass that could be used as part of a new green carbon economy. 50% of that biomass is going to be carbon, and so we have 500 million tons of renewable carbon that we can use for energy, food, climate-friendly buildings, healthy soils, clean water, and clean air. Back in the beginning, we were just looking at soils, and we've extended to other possible uses and looked at biochar in relationship to the overall green carbon economy. So if we recover half of the carbon as biochar, we can sequester it 250 million tons in soil, building products, and so on. They're equal to about 625 million tons of CO2 equivalent. So that's equal to the ecological footprint of 39 million people, or it would take about 135 million cars off the road. So to kind of look at that graphically, back in 2007, Dr. Johannes Lehmann told us that we should be taking that 500 million tons of carbon and in its various forms and pyrolyzing it, converting it to transport fuels, energy, co-products, and industrial products, and putting 50% back in the soil to help regenerate the soil, and again, that would could theoretically sequester about 625 million tons of carbon dioxide. And we have a number of markets that have evolved for biochar. So first off, if we follow Dr. Lehmann's path, then we'll make transport fuels. On the left-hand side, you can see a picture of the groundbreaking at a sustainable aviation fuel plant. There are a few of these plants that are in construction. This particular one is Red Rock Biofuels in Eastern Oregon. They intend to make a sustainable aviation fuel, and as a co-product they will have biocarbon, which could be used as a and also biochar, which can be used in soil. In the next slide over, the next picture over, the plant, the Restoration Fuels plant, newly constructed in Oregon, will produce torrefied wood, but could also produce biocarbon and biochar, but in lesser quantities. The AirX Energy system in Canada is being promoted both for torrefaction and for fast pyrolysis to make oil and char. So you can see the markets here as we go along. Autothermal pyrolysis is a new technology that came out of Iowa State University. Their first plant's being built in Iowa. It'll make an oil and a char and can make a refined gas or renewable natural gas. And then the char technologies that I showed before has various paths to go from biochar to biocarbon or to renewable natural gas. And each of these, of course, has a value chain that winds up with some market value composed of brokers, distributors, retailers that bump up the cost of things. But at the end of the day, we wind up with products that carbon products that we as consumers enjoy or use. And here are some pictures of some German biochar products. These products are made out of biochar. You can see the bioplastic up in the upper right-hand corner that is made from biochar. They make these carbon tiles in this particular product. And these tiles, you can see, are the facade of an Audi outlet in Germany. And they're not limited to the tiles. You can see on the left, the sunglasses the lady is wearing are also made of biochar. So you can see that biochar, through various links, winds up getting into consumer products. And you can find these products at Made of Air. The URL is there, and also a URL for a design site that talks about carbon products from biochar. So biochar has also finally gotten into the international market for carbon credits. We have carbon removal markets that increase the biochar value. So you can make the biochar, put the biochar on the ground as long as you recover energy in the process of making the biochar. Then you will have a multiplier, in effect, that will result in your ability to sequester about 2.5 tons of carbon dioxide equivalent per ton of biochar. And so we have companies in the U.S. and in Europe in particular that are getting these carbon credits, selling the carbon credits at a market value equivalent to, in this particular case, late last year, about $350 per ton of biochar. So it goes a long way for subsidizing the production of biochar. And these standards they're based on standards that started with the International Biochar Initiative, evolved with the European Biochar Certificate. There are new standards under development by Vera in the U.S. and by the Climate Action Reserve in California. The primary markets are Puro Earth, which now has been heavily invested by NASDAQ, and Carbon Future in Germany. And we're looking forward to standards and markets from Vera and Climate Action Reserve. And all of this is attracting the attention of the corporate decarbonization movements, the environmental, social, and corporate governance emphasis that companies like Microsoft, Starbucks, and Shell and others are pursuing. So a lot of people are optimistic and see an increasing value, which can help offset or subsidize the cost, hopefully, of removing biomass from the woods that for other purposes and recovering it as biochar. So does it make sense for the producer? Right now, it looks like you need a minimum production of about 500 tons of biochar a year, equivalent to about a 2-megawatt power plant, with biochar at about $150 per ton of biochar to make it worthwhile. But one thing that people who are selling biochar credits are telling us is that just the fact that they're selling carbon credits is evidence of environmental stewardship, if you will, and that's attracting investments from some of these large corporations. So here is the example I showed earlier of carbon recovered from biomass combustion from a biomass plant. This material is going into the soil. It's going into either directly into the soil or going with compost. There are a couple of suppliers that are both selling on the carbon market, Pacific Biochar and Oregon Biochar Solutions. And so we have this functioning in the marketplace, and we're taking forest biomass and developing not only carbon removal credits, but also applications in the soil and carbon sequestration. You've seen, I'm sure, pictures of these. Maybe you've used these smaller flame cap kilns, the char boss for use for hand piles, smaller scale activities. Still a method for, in forestry, recovering carbon and improving, reducing hazardous fuels, and also improving the revegetation and regrowth potential. And so the insurance folks take a close look at insurance risk. They say there are 4.5 million homes that are at risk to wildfires. We clean up the woods. We can have the benefits of clean air for rural communities, rural employment and recreation. We had, up to June this year, we've had 30,000 fires already, 1.5 million acres or 1.4 million acres burned. The last 3 years, we've had 50 to 58,000 wildfires, burning everything from about 5 to 10 million acres. And so obviously the fuel reduction is important, and it can be even more interesting and more important if we can also recover carbon. Of course, we don't have to recover the carbon directly in the woods. We can grind it up, put it in trucks, and haul it to either biomass plants or biochar facilities, but that's logistically not always possible. Here's a device we demonstrated a few years ago, and now there are probably 50 or more of these things operating not only in the U.S. but around the world. We see them in Australia and other places. It's basically a mobile carbonizer in which you can not only reduce the volume of the wood residues you reduce from wildfires, but you can also produce biochar as a co-product, and you can see in the lower right-hand corner there's biochar recovered from wildfire debris from a fire we had here in Oregon last year. We also see these modular pyrolysis systems being developed. This is a 40-ton and up to 40 tons per day, relatively small, but these things can be placed at sawmills and other locations in the woodshed, if you will, that are logistically close to the woods so that you could create biochar, generate either power or heat for use, and send the biochar on downslope for use in agriculture and other applications. And what is it about biochar that ties this green carbon economy together? These are, I'm sure, familiar pictures to you. On the left-hand side, we have the chemical and physical properties of biochar, that structure that allows the high surface area for chemical absorption, the porosity for air and gas, and in the center we have the biological activity that biochar is known for. But on the right-hand side, we have a study that talks about the use of a biochar-based fertilizer increasing the redox potential, reducing the amount of energy that it takes for the plants to take up nutrients. And so the concept here is that biochar acts as a biogeobattery, and it enables the recycling of nutrients and so on in the soil. And even bioelectrochemistry becomes involved, because the organisms that thrive in biochar can generate their own electricity. There's even a sensor that is powered by the electron transfers, the organisms, and for use in monitoring soils. And that is facilitated by biochar, by the carbon. So you can see in this way, as we move forward, we're going to see, I think, more and more of this carbon used, carbon sequestered from biochars in a number of different applications, even including medical sensors and those kinds of applications. So as we know, biochar amendments improve nutrient use, adding value in horticultural, landscaper, turf, and trees. You'll probably find this in your backyard, actually. If you go to your local garden center, I can buy this Kellogg Garden product, which is biochar amended. The biochar addition to these growing media increases the value by about 2 times. In the particular case on the right-hand side, the Green Frontier Compost by Missouri Organic Recycling, they claim they wind up with about 16% biochar by finished volume, which would be about 8% by weight. They've added a couple of other ingredients, but they've doubled the value of the char, and they're selling this by truckloads. Now, one of the advantages that they see in particular is that it allows them to compost some of the more difficult materials that have odor and so on. The biochar offsets the odor, and it also increases the value of the compost. So in terms of the linkages, you're going to find biochar amended products. I'm sure you can find biochar amended products in your local garden center, if not in your backyard. And here's a testimony to the Missouri Organic Recycling product, the Green Frontier Compost, that shows that, yeah, the biochar works and it does add value, and it does affect all of us. And here's just an example from our friend John Nielsen at Chargrow, listing the advantages of adding biochar to compost. So whether you're hauling wood out of the woods or taking wood residues from a mill, carbonizing it, combining it with organics locally with all of these benefits, odor being one that is a particularly prized benefit. So biochar applications are growing. I'm sure you've seen this list, but this is basically these are the general biochar markets that we see. This is where biochar touches you: in agriculture, retail, garden, landscape, turf, and horticulture. In environmental remediation, filtration, stormwater filtration. All of these markets are growing very slowly. It takes a while to put the regulations in place and enable the specification of biochar for various uses. But we have continuing research which monitors and shows us that biochar has qualities that we keep discovering in water quality and in forestry and non-carbon soil products. We see some farmers, contractor on the left-hand side using a no-till drill, using combinations of biochar and fertilizers, whether they're organic or biochar-based fertilizer, and even liquid suspensions with no-till drilling. I like the phrase on the right-hand side. Jason Mock, Constant Canopy, who's a no-till farmer in Indiana, says biochar is a change agent. He's had very good luck with biochars in his no-till operations. And strip tillage, which is less used, the story of J.R. Bollinger is pretty well known. He's increased his soil carbon from less than 1% to more than 3.5% in 5 years using biochar along with other organic amendments. So you need the full meal deal. You need all the components to make the growth happen. But what he's done, he feels, is stimulate. Not only has he increased soil carbon, but he's stimulated the biological carbon sequestration, so that he has, as I say, increased his carbon from less than 1% to over 3.5% in the last 5 years. So this is a success story, but it's hard to transmit this success to neighboring farmers. Just look at JR and say, oh well, JR's doing his thing. We're not gonna try that. Biochars are now complementing beneficial supplements. We see biochars now being used as carriers for formulated products like the American Biochar Company Vital Blend on the left, and as a carrier for humic products from the Andersons here on the right. So these are nationally distributed soil amendment products, biochars reaching out and getting into your backyard. Biochars of liquids are injected and sprayed. Liquid forms of biochar are becoming popular amongst arborists because it's easy to handle. I remember handling liquid chars for carbon banding in agriculture and not liking it as a liquid at all, but it's better than the dry, dusty stuff. On the right-hand side, you can get a product that's either liquid or granular from Lesco, which is owned by John Deere. It's called Carbon Pro. It's biochar-based. Basically, it's a biotic soil amendment. So they add biologicals, add fertilizer to the biochar, and you wind up getting these benefits that they're claiming here on the right. And these are available, again, in wholesale distribution throughout the country. One of the fundamental use of biochar and biochar with compost is improving water retention, of the compost, improving water retention of the soil, but there are other benefits as well. So it's likely the tomatoes you eat, if they're from California, may have had a biochar amended substrate, which has helped to preserve water and reduce overall irrigation. And they found in the process, we have a few farms that are being monitored in multi-year monitoring, and we're finding even additional benefits from the use of biochar amended compost. And also we have now the Natural Resource Conservation Service, USDA EQIP program, provides cost share funding for the use of biochar with compost. That program was introduced in 2019, but is only just getting started. We hope that that will expand the use of biochar in agriculture. And I think in the future, you're going to wind up seeing the benefits of biochar in your food. As the slide shows here, animals inoculate, distribute, and mix biochars in soil, improving forage, animal health, and soil health. This is being realized in Europe and in Australia, and even in Africa. In the United States, it's illegal to feed biochar to animals. There are feeding trials underway that hopefully will change that, but we're finding that what biochar does is it acts very much like roughage in the rumen, but it does more than that. It winds up getting inoculated, passes out into the with the dung, and then the dung beetles will take it down into the soil and improve the quality of the soil. So there are a number of benefits that are claimed for the use of biochars. Woody biochars are also being used in conjunction with sewage sludge and manures. So here the sewage sludge and manures in these processes are being carbonized. You can see from VOW, ETIA, the BioGreen company, that they've been doing in the upper left-hand side. They've been doing wood chars for some time, and they're converting those wood chars and the biosolids chars into a variety of products: acetic acid, biochar, and other carbon, oil and carbon products. So we're seeing an evolution of technology at the small industrial scale, which is beneficial. And I think what it's going to do is make it more profitable finally for smaller industrial scale systems to work. This slide I love to put in because it illustrates that you can take biochar in a relatively simple form and have some great benefits when you combine the biochar with manure. Let the two act together, let the biochar help you manage the nutrients, and you wind up with, here Sister Miriam Paulette on the left-hand side is making biochar in a simple pit kiln, and using that technique. Everline in Kenya on the right has been using the biochar manure combination, and it's getting this healthy bumper crop of corn compared to a poor harvest with synthetic biochar. So it's a more dramatic illustration, and they tell us that biochar is a farmer's best friend. So I think that conveys to me the idea that biochar is more of a helper, if you will, in agriculture, and it certainly is in our garden. So I think as eventually, I think we're going to see fossil fuel prices go back up or increase. We're going to see the need for the application. This happens to be in Australia. But when you buy your herbs, it may well be that they're grown in a greenhouse where wood is delivered to the greenhouse where the arrow is, goes through a pyrolyzer, generates electricity, generates heat for heating the greenhouse, makes biochar as a co-product, and that biochar is taken back and co-composted with food waste and so on into a growing media. We haven't seen that quite yet in this country, partly because of our low cost of natural gas and other sources of energy. But I believe that we will be seeing more of that kind of integration of heat and biochar in the future. And in the forestry sector, I mean, this is a block of seedlings from a nursery in Northern California about 10, 12 years ago, about 10 years ago. We started using biochar in this nursery, but the biochar is a co-product of heat from a gasifier being used to heat a couple of greenhouses. We started experimenting with the biochar as an amendment to the growing media. and wound up replacing vermiculite. Vermiculite is mined in China. It's heated up with natural gas to become puffy, so it has a lousy carbon footprint. It's hauled around the country as so much air. And here in this case, we substituted the vermiculite for biochar and found that we could actually substitute all the vermiculite for biochar in this particular growing blend without any effect on the trees. Another use of the biochar in reforestation and outplanting. We have a forester here in Oregon that has used biochar and amended the biochar, soaked it in phosphorus or other components that are lacking in the soils that he's reforesting, and used the biochar as a component in outplanting. And so here's another use of biochar in reforestation. Putting biochar into seed balls. These happen to be pictures in Africa, and the one on the right with the drone in the U.S. We've made seed balls of various kinds and seed coatings with biochars. There's some tricks to doing it. They work particularly well with acacia species, which is why they're working well in Kenya. Literally tens of thousands of acres of reforestation has been done using biochar seed balls in Kenya, less so in the United States. But another potential forestry application where appropriate. So with biochar, then with forestry, we can go the full circle. We can make the solid wood products, we can chip up the residues, generate a feedstock for a gasifier, produce heat for the greenhouse, make biochar as a co-product, use it to grow the seedlings, wind up using biochar as a growing media, and also sell it downslope and off to the external markets, sell the seedlings, reforestation, and we have can go the full circle. So other markets and other linkages, other uses that may not be obvious to you with biochar, environmental remediation. It's being increasingly used in stormwater. Add 10% biochar to hydromulch. You can have it improves seed establishment on some very poor slopes. You can use it in water treatment systems, removing leachate from chemical oxygen demand. Also, a lot of good work has been done on using biochar for reducing organics. If you have a tree repaired, as a friend of mine did in his garden, you may find that companies like Bartlett Tree Experts are using a media around the soils. They'll use an air spade and dig around the soils and replace it with a media that's been inoculated with organisms. And in that carrier mix, my friend asked the Bartlett folks, he said, do you have biochar in that mix? And the fellow looked around and said, how did you know? I think that was supposed to be a secret. But Bartlett has been using biochar for a number of years now as a regular part of their mix. And we're seeing more and more interest, again, from arborists and using biochar to help basically correct soil problems and to result in healthier trees. Other applications in the upper left-hand corner, woody biochars are being used to generate heat, and then the biomass is being used to generate heat. The chars are being used in structured soils to repair street trees and in green roofs, and also in bioreactors for sewage treatment. We're seeing a little bit evolution in building products, these CMU blocks on the left, the asphalt in the center, combined biochar and plastic. These are development products that aren't really on the market yet. There's some masonry products. And as I said, there's a lot of research and experimentation with regard to the electrochemical properties of biochar. And here on the right, you can see some experimentation with sodium-ion batteries. So when you've got a solar array, you need to store the power someplace, and we'll store it in biochar. Just an indication, this hasn't been updated recently, but it's an indication of biochar production across the United States. We have kind of a void in the Northeast, but we have 2 or 3 new plants that are being developed. Most of the biochar comes from the west, Colorado west to California, Oregon, or from the southeast, from the pine mills in the southeast. So forest and wood industry residues can be major sources of carbon for value-added products to catalyze a green carbon economy. We need cheap sources companies that are specialized in carbon products for low value and large volume markets. We see a growing demand for biocarbon for wastewater treatment. We see carbons enhancing composting. We see additives, metals and enzymes to improve the quality of those compost products. Biocarbons are renewable reducing agents for metallurgy. Particularly in Canada, we see a push to use biomass, convert biomass to biocarbons for use in metallurgy. Of course, you don't sequester carbon in that application, but you do offset the use of natural gas and oil. So biochars are being modified to enhance their performance for a number of different applications, increasing the surface area, oxidizing the surface to improve surface functional groups, nitrogen doping. Lots of literature, about 10,000 peer-reviewed papers or more I see. We're actually running about 2,500 a year. We're seeing carbons that are functionalized as catalysts, fuel cells, for use in batteries, for use in electrodes. We're seeing carbon nanotubes, discovering that carbon nanotubes are actually an active actor or ingredient of wood vinegar. We're seeing the evolution of carbon gels and carbon fibers. What we need to do is train an army of green carbon experts all the way from the woods to industry and conversion. So in summary, biochars from industry and forest biomass can produce renewable energy, sequester carbon, increase soil carbon, increase value, reduce wildfire risk, restore forest and soil health, improve animal health and food security, improve water and the environment, and help build a green carbon economy. And so that's what I have. Thank you very much. Certainly open to any questions, but I think you can see, hopefully I've illustrated the links of biochar to a wide variety of applications. So I think we're open for questions.
Yes. Our organizer is going to announce that.
To ask a verbal question, please press #2 on your telephone keypad. You'll hear a notification when your line is unmuted. At that time, please state your name and question. Once again, pressing #2 will indicate that you wish to ask a question verbally.
Can you tell them also too?
Okay, Brennan asks, thoughts on production of char from MSW. Safe application, does it count for carbon credits? So far there isn't a protocol for carbon credits from MSW for municipal solid waste. I think eventually there will be. The carbonization of municipal solid waste has been worked on in various other countries, and it's being seen as a way of basically inerting and putting MSW into a sequestrable form. But I think it'll be a while before we see I think the application is safe, to answer that question. And as evidence of that, we ran for about 15 years a gasifier in the Midwest using a variety of wastes, and the chars from that gasifier never once failed a toxic leachate test. So it is, I think, biochar is an interesting form of tying up ash from municipal waste. Has the oil and gas production from biochar technology reached the point of being net energy positive? Yes, I think the answer to that is yes, in particular with this more recent autothermal production. And the net really is the issue is that you're using a renewable fuel source to drive the process. What is the cost of biochar products compared to compost? What's the difference between compost and biochar? Well, compost and biochar obviously are not the same. The compost has a wider variety and also contains nutrients, whereas the biochar is more of a substrate. Biochars are much more expensive on a dollar per cubic yard range than compost. Compost can be in the compost basically are paid for. It's the conversion of residues to compost, and it's paid for largely by the homeowner or whoever's disposing of the food waste or whatever. And so what you pay for with compost is transportation plus a little bit of margin. So composts are in the $15 to $30 a cubic yard range, whereas biochars can be in the $80 to $100 cubic yard range. But a biochar amended compost can be anywhere in the $50 to $60 cubic yard range in between. And biochar adds significant value to the compost. So those are just general numbers. Don't go to your compost vendor and say, well, Tom said it's only worth this much. That's all I'm going to pay. How are biochar waste from water treatment managed? The Energia, which is a large company that produces water treatment equipment, did a year-long test that was funded by, I think, the Department of Energy, might have been the EPA, anaerobically digesting biosolids from water treatment and then drying and carbonizing those biosolids and making a biochar. And the biochar had, by all accounts, excellent properties and was non-toxic. And I think the water treatment issue, we've done work with sewage treatment plants and biosolids, and I think there's a difference between biosolids from residential sources and from industrial sources. Some industrial sources contain heavy metals and are treated differently than the biosolids from residences. Would you discuss the projected economic feasibilities through the eyes of producers, marketers, and users? Well, that's a great question. I think the answer to this is our friend David Yarrow says you got to walk on two legs. You need to use both the char and the heat from the char. And so the economic feasibility really depends on your ability to recover that other 50% of the carbon or 25% of the biomass in some form, whether it's oil, renewable natural gas, whether it's heat. The simplest use is direct heat, although it depends on where you are or what the value of that heat is. But we see systems that are economically feasible where you're really recovering both the energy in some form or that oil, whether it's sunglasses or external tiling, but in some value-added product. Well, that's from the biochar and even from the oil. You can take the oil on into elements components that then you would polymerize into other products. So I think that we are beginning to see the evolution of products that make it more feasible. But in simple terms, as David says, you got to walk on two legs. Are there presently any standards for measuring the relative effectiveness of different types of biochar? That's a great subject of probably not going to get in too deeply with our upcoming International Biochar Initiative webinar. But the point is, from a standards point of view, the standard metrics measure the qualities of biochar, and the qualities of biochar, again, determine the use. So from an agricultural point of view, we actually have a tool on the International Biochar Initiative website in which you can enter the qualities of the biochar that you have, whether it's in that 10 to 30% carbon range, which would be the manures, the biosolids, the 30 to 50% carbon range, which would again be manures but be agricultural residues, or the 60% carbon plus range, which would be primarily the wood range. So it's really looking at the effectiveness depends on a lot on the soil, what problems you're going to solve, and the crops, and then matching the biochars to suit. And that's one of the challenges we're trying to address in the U.S. Biochar Initiative and also in the International Biochar Initiative, and that is how do we find simple ways of making that match work. So from Linda, why do you think there's a void in the Northeast with so much forest land? What needs to happen there? Which is simply that actually one of the early biochar producers was high carbon fly ash from a biomass plant in, I think it was New Hampshire, which was combined with compost in Vermont and actually solved the problem with residual herbicides in composting in Vermont. There's a lot of interest, a lot of excitement in the Northeast. There are a few plants that are being developed. I think one of the issues is that a lot of our biomass plants have shut down because of the low cost of electricity. It's not feasible for them to generate power, and the older plants are the ones that you typically can recover the char from to develop and build the carbon market. But we have new plants going up in Maine, in New York, in Pennsylvania. These are all relatively small facilities, but I think they will do a lot to drive the market. Okay, Jean-Francois, generally speaking, is biochar made from whitewood very different from biochar made out of bark? Which is the cheapest available feedstock? Let's go to the cheapest available feedstock. Right now, the wood market, the wood residue market, as one of my clients in the Southeast told me yesterday, is going absolutely crazy. There's a lot of demand for wood residues, both clean residues and also bark. And so prices are going up, costs are going up for wood residues for an industrial plant. The cheapest available feedstock, obviously, is something that nobody else wants, and that becomes, these days, the big pellet mills, for example, want white wood, they want clean wood, and so the cheapest feedstocks typically are hog fuel that are mill residues, but those are usually used up in most areas, and so then you would have to go to forest residues that are not cheap. The biochar is made from a combination of woods and residues. The difference between whitewood and bark basically is the ash or mineral content. In whitewood, you've got 0.5% to 1% ash or mineral. In bark, typically you'll have 3 to 5% intrinsic ash, and then you'll also have, in addition to that, the ash and minerals that may have been blown into the bark or dragged into the bark from logging. So you have slightly higher ash component from bark, but what's interesting, though, is what we see in biochar products made from hog fuel. The ash contents really haven't been that high. Jorge Lopez, have you heard anything about using biochar as an herbicide in agriculture? Not as an herbicide. Biochar tends to tie up herbicides. I think the herbicide application you're probably referring to is the wood vinegars, the oils and vinegars kind of products have been, they've been experimenting with more fungicide than herbicide. So I really don't know the answer to that question. John Porterfield, is there a pilot study for pyrolysis in the woods with biochar applied at site or transported for agricultural use and pyrolysis gas used to pyrolyze and provide electricity connected from the woods to the grid? Renewable electricity. I'm familiar with air burner equipment and this capability. The conversion rate of electricity with the mobile devices like air burners unit or the Tiger Cat unit, which will eventually have probably electrical generation, is very low. In a biomass plant, you can generally look at about 1.2 megawatt hours per dry ton of wood. It's very much lower than that, generally with both smaller systems and portable systems and heat recovery systems, organic rake and cycle turbines, as they're called, that are used with the air burner type of equipment. So yes, you can generate power. You're generating it at a much lower efficiency. Back in 2004, we did a study in eastern Oregon of 26 different sites in central Oregon, looking at the potential of making biochar, that was when we were calling it terra preta, and oil, and using the oil as a fuel. What we found was a number of former sawmill sites that had concrete slabs and extension cords. They had power connected. And so those would be ideal sites for those modular biochar or the modular pyrolysis systems, which would allow you to generate biochar and power. But the marginal cost of generating power is high. It's expensive to generate power. So you need to see generally power prices in the order of 20 cents 22, 23 cents per kilowatt hour to be able to justify generating power, even in a central plant. We see some very successful applications, in particular in Austria, a company called Syncraft, making a very efficient gasifier system that produces biochar as a co-product, and biochar is with a high enough quality to be used as feed. Is there a guide or handbook for small CA, Canadian logger or California loggers, to use biochar as disposal? Good question. We should do that. We should put together a handbook. I think that's a great idea. We actually have USBI, again, as a volunteer organization. We have an education committee, a communications committee. Both of them are working on developing fact sheets, developing guidance documents, again, with the help and the support of the Forest Service. And we encourage you all to donate. We can always use funding for generating this information and getting the word out. So, Christine, when used in biofiltration practices, does biochar remove phosphorus from water entering the practice so that the effluent has a reduced phosphorus content? Biochar alone does not reduce phosphorus. Biochar needs help, typically iron and other components to increase what's called the oxalate number for reducing phosphorus. There are a number of different combinations that people are working on with biochars. There are biochar products that can reduce phosphorus, but biochar on its own does not simply filter out phosphorus. Early on, some work in Germany showed that composting biochar or co-composting biochar with organics improved the phosphorus retention by creating functional groups on the surface of the biochar that would capture the phosphorus, and that work has gone further. So there's some great work out of Australia, some good work right here in the United States, some good work in Europe on phosphorus capture. So we're getting there, but you can't just make the biochar and use it directly. Good. Well, I think that's so far. Those are the questions that have come up. We've got a few more minutes here if anybody's got any further questions. Again, I would encourage you to go to the U.S. Biochar Initiative website, biocharus.org. You can contact us at usbiochar@gmail.com. You can also join the biochar discussion group at biochar@groups.io. And again, we've got about 1,000 people on that list, about 1,100 people on that list, many with a lot of experience with biochar. Can you tell us whatever you know about biochar as a feedstock for battery and carbon nanotubes? You can do, I would suggest, do a Google Scholar search. Just search Google Scholar, biochar, carbon nanotubes or carbon battery, and you will get an abundance of academic papers on the use of biochars in batteries, and you'll find a lot of information about the qualities of, again, the electrochemical qualities of different biochars. There's just a tremendous, there's actually a book, an online book that we published out of Italy last year. I wrote an introductory chapter to that deals with nothing but the electrochemical properties and applications like batteries and so on for biochar. And don't have the URL for that book, but send me an email at usbiochar@gmail.com, and I can certainly send you the link to download the book. It's a there's a price on it. It's not free. As an information broker friend of mine said back in the late 90s when we were first getting into, or late 80s when we were first getting into online and internet information. She was an information broker and said, the good information you'll still have to pay for. And I think that's still true to a certain extent. But send me an email. I'll be happy to send you a link to some reference information. All right. Well, I think that's it.
Tom, thank you so much. This was a great webinar. Thank you, thank you. Thank you, everybody.
Well, good. Just add biochar.